Welcome to Learning to Fly FPV. This class is going to be a little bit of miscellaneous stuff. We're going to talk about RF power, uh, RF frequencies. We're going to talk a little bit about actual power, so your battery. To start off with, we'll hit radio frequencies. So common frequencies within FPV are going to be 2.4 gigahertz. That's generally going to be your control link. 5.8 gigahertz, which is going to be your video downlink. And then 915, which is also going to be your control link. So most of these, when I say 2.4 or 915, it's not that on the dot. It's going to be left or right a little bit, but that's kind of just where it sits. So here in the US, we have the FCC, which is the governing organization that controls where things are in the spectrum. Okay, so when I speak about spectrum, I'm talking about the radio spectrum, which is where everything wireless communicates off of. So anything from walkie-talkies, your cell phone, the Wi-Fi, and in our case, FPV control link and FPV video downlink. Depending on your country, it's going to be different, more than likely, okay? So just double check. More than likely, you can't get things outside of your frequency within your country, but just make sure you double check what your frequency you're running on. That being said, what I'm about to talk about is in the US. So for us, when we talk about channels or when we talk about bands within FPV, there's certain bandwidths at certain frequencies assigned to certain channels. So what this allows us to do is it allows, as we have multiple pilots, we can assign different channels so that we're not getting other people's video feeds. For analog, I always recommend using the race band. Okay, so the race band was set up so that you can have a lot of different pilots, 8 channels that don't interfere with each other. Sometimes they do, depending on power outputs and other stuff. You can get interference, but we'll get into the propagation in a bit. For programming your drone on what video transmit system you're going to use, it's going to depend on whether or not you're analog or HD. Fat Shark has their own bands and their own channel, just like DJI does. The other bands are analog. Most people fly on race band, which is what I recommend, just because there's already that gap. So there's different bands for you to fly on. I put on the screen a quick sheet of all these, but let me explain them to you real fast. So all of these, if you look, there's certain band widths, which is the frequency from, just for simple math, we'll say you have a frequency band from 100 to 150 megahertz. Not what we're flying, that's really in like the radio spectrum for like FM, but just for simple math. So from 100 to 50, if that is one channel, you have a 50 megahertz bandwidth for you to utilize, okay? That is your channel. If somebody is also in that channel, it will interfere with your video system. So that's where all these bands and channels come in. So it allows you to fly with multiple people around you, i.e. races or just flying with your friends, and you cannot interfere with their video system. If you're running analog, I recommend the race band. If you're running DJI or Foxnail, it's better to have an offset just so you don't interfere. So you have your channel and you're broadcasting. How is it getting from your drone to your goggles or your controller to your drone? Doing that obviously via antennas, but there's different types of antennas. So you have an omnidirectional antenna, which looks like this. So you have an SMA cable down here, plugs into your goggles, antenna, and the top of the antenna here. That's an omnidirectional. Or you have a directional, okay? So notice the difference where you have kind of like this cylinder on top and you have a cone. That's pretty much how it's broadcasting, right? Broadcasting everywhere in a giant circle. It looks a little bit different than that, but generally speaking, a big sphere. And this looks more like a cone. This has a degrees, this doesn't. Each one of these have something called gain, which is basically its sensitivity. These are going to be higher gain, which means that they're going to be more sensitive when they're receiving a signal. But it's harder for them to receive a signal if they're not facing that direction. This is going to be less gain, so less sensitive, but it's going to be able to receive from pretty much any direction. You might hear something about polarization. Most of this comes into fact when we talk about it, about video transmit systems, both from the drone to the goggles and how they have to match. So on your screen, you're going to see a picture right now. So these are just some of the types of polarization, but generally think of it a wave traveling through the air, right? And as it travels through the air, it follows a certain path. If, for example, so this is a linear antenna. If, for example, my waves are coming out here, they're going to go at this angle. If I flip this over, now they're going to go this way, okay, back and forth. Circular polarization works just like that. It is in a circle. When you have a misalignment or mismatch of polarization, you're going to have a loss in dBm, or the measure of how of power at the receiver. Okay, so if I have a left hand circular polarized antenna on my goggles and I have a right hand circular polarized antenna on my video transmission system, I'm probably still going to receive that transmission for a while until I reach a certain range and there's loss. Okay, so the reason why we do this is so that it interferes less with other systems. Okay, you have a linear antenna on a video transmit system, it happens on whoops a lot. But most commonly, you're going to see right hand counterpolarized or left hand counterpolarized. So radio propagation, it's basically where the radio waves go. Okay, you can get into the weeds on propagation and propagation theory and stuff, but just want you to understand things that are going to interfere with your signal. So it's going to be terrain, so mountains, valleys, hills, buildings, specifically concrete. If you're flying in a bando, you're going to lose link probably eventually because those radio signals have to get through all that concrete before either gets to the drone from the controller or to your goggles from the VTX. Trees or foliage in general. So like if I'm flying from behind a bush, if I'm going in front of that bush, I'm going to have an inherent loss. 2.4 and 5.8 are considered line of sight, which means you're going to have the best transmission and the best receive when you can see the drone. Okay, you don't have to actually see the drone, which you do according to the FAA, but you don't have to see the drone to necessarily have line of sight in terms of transmission. I know that's a little confusing, but radio waves bounce. There's different pathways for them to travel. But generally speaking, if you can see the drone, you should be able to get video feed. So we're going to shift into batteries. This is a 1400 battery, 120C, 6 cells, 2.2 volts with 31.08 watt hours from Tattoo. What does all that mean? Well, we're going to start by talking about components and then we'll get into it. So you have a main lead, you have a battery lead, which is this. This specific adapter is called an XT60. There's other ones that exist that are XT30 or XT90 that have to do with the size. Most commonly on like 5 and 7 inch, you're going to see an XT60. Then you have what's called the balance lead. So the balance lead goes from the lead to all the individual cells. And what it does is when you plug it into a charger, like this one, or the one you see over there, it allows the charger to charge individual cells instead of the battery as a whole. You can get into a cell mismatch, which can damage your battery and really cause some problems for you, but this helps to get ahead of it. Okay, so I said 6S or 6 cell. What does that mean? So each one of these things right here are individual cells. In other batteries, it could be like an 18650, but in Tattoo batteries, it's going to be these little cells. Okay, so your cells, if they are LiPo, are going to be charged to a maximum of 4.2 volts. Okay, if they're high voltage, they're going to be 4.35, a little less common. And if they're Li-on, they're also going to be charged 4.2 volts. Okay, the 22.2 volts that I mentioned earlier is the nominal voltage. Okay, so the nominal voltage of a LiPo or Li-on battery is going to be 3.8 volts, with the maximum charge again of being 4.2 volts. So where does that 22.2 come from? It's the nominal voltage times the cell. Okay, so if you're looking at a battery and it says 22.2 volts, you have a lithium ion or lithium polymer battery that has 6 cells. Okay, C rating. I said 120C. What does that mean? Well, C rating simply refers to the maximum amount of discharge that's safe. So max C rating or max current draw equals capacity times C rating. Higher C ratings mean they can be discharged faster. Lower C ratings mean they can be discharged slower. You may have heard the term parallel or series. Okay, generally speaking, with high milliamp hour batteries, you're going to have some in parallel. The way parallel works, which there's an image on your screen kind of showing you a picture of it, is that they're paired together, but instead of increasing the voltage, I've increased the total milliamp hour. So if I have two 1400 milliamp hour batteries here at 6 cells and a 22.2 volts respectively for nominal, I'm going to have a 2800 milliamp hour battery that's still at 22.2 volts. If they're in series, I'm going to have a 1400 milliamp battery that is 44.4 volts. Okay. I'm using nominal just to make it make sense. Generally, think of parallel as more fuel in your gas tank and series as a larger input. So safe charging. Okay. Safe charging, it's always safe to charge at 1C, which means if I have a 1400 milliamp hour battery, I can charge it at 1.2 amps. I charge at 2C personally, which means I charge this battery at 2.8 amps. Whenever you're charging, especially when you're charging a lot of batteries, always be in the area. Okay. Look up a video of unsafe charging or lipo explosion or something like that, and you'll see that this expands. You hear it starts fizzing, and then it bursts into flames. Not great in your garage. Nobody likes a house fire. All right, that's it for RF propagation batteries. I know it was short. I wanted to teach you guys a little bit about RF propagation and antenna theory, as well as safe charging for batteries. Always do your research. Always know what your frequencies are supposed to be, especially if you live outside the US. And always, always charge safely.